You know, we use the internet pretty much every second of every day, right? But do we really know how it all works under the hood? Well, today, we're going to follow a single piece of data, a tiny little packet, on its incredible high-speed journey from your screen across the entire world and back again, all in literally the blink of an eye. It all starts with something so simple, something you do 100 times a day. You click a link, and like magic, a web page from halfway around the world just appears. But what you're really seeing isn't magic at all. It's the end of an amazing journey. I mean, it feels instantaneous, doesn't it? But in that fraction of a second, this incredibly complex, beautiful dance of technology unfolds across a global network. So let's break that journey down step by step. So our packet's journey begins the very moment you click. That simple action creates a message, a request that has to be sent out into the world. Your click, it generates what's called an HTTP request. This happens at the application layer. That's the part of the internet your browser is actually talking to. Think of this request as a digital message to a server, basically asking, hey, can you please send me the contents of this specific web page? Now, you can't just shout that request into the void and hope for the best. Before it can go anywhere, your message needs to be carefully packaged up and prepared for its long trip. And honestly, the best way to understand this is with the classic postal service analogy. Your HTTP request is the letter itself, but that letter needs an envelope, an address, and a stamp before it can ever be delivered. This whole packaging process has a name. It's called encapsulation. Basically, each layer wraps the message in a new envelope with more instructions. First, the transport layer, using a protocol called TCP, chops your request into numbered pieces, or segments, to make sure nothing gets lost. Then the internet layer slaps on the destination IP address. That's the mailing address for the server. And finally, the network layer puts the whole thing into what's called an Ethernet frame, kind of like putting it in the local mail truck for the first leg of its journey. Okay, so our packet is now this fully addressed, self-contained little unit. It's ready to go, but where exactly is it going, and how on earth will it find its way? So for this to work, you need two critical addresses. The IP address is the big one, the global destination, like the city and street you're sending the letter to. But for that very first step, just getting from your computer to your router at home, the packet uses a local MAC address. This is a unique hardware ID, kind of like telling the mail carrier how to get the letter from your desk to the mail truck waiting outside. Once the packet leaves your local network, it hits its first router. And let me tell you, these devices are the unsung heroes of the internet. A router has one job: look at the destination IP address on a packet, and in a microsecond, decide which direction to send it next to get it just a little bit closer to its final destination. But the internet isn't a single straight road. It's this massive, tangled web of connections. So how does your computer find the best path through it all? Well, it maps it out in real time, using a really clever trick involving a packet value called time to live, or TTL. Here's how it works. Your computer sends out a few little scout packets. The first one has a time to live of just 1. So it only makes it to the very first router it sees, which then reports back. Boom, first step of the map is down. Then it sends another scout, this time with a TTL of 2. This one zips past the first router and reports back from the second router in the chain. And this process just keeps repeating, increasing the hop count by 1 each time. And in a flash, it builds a complete step-by-step map of routers all the way to the destination server. Now, your actual data knows the exact path to take. It's brilliant. All right, the path is mapped. The packet is addressed. Now for the main event, the journey across the digital highway of the internet itself. And now, the packet is absolutely flying. It leaves your local network and hits the wide aerial network, the global backbone of the internet. We're talking about these massive fiber optic cables laid under oceans and across continents, just pulsing with light. The packet bounces between dozens of routers in these huge anonymous data centers, each one making a split-second decision, keeping it on the fastest possible path to its destination. So, after a journey that might have crossed thousands of miles in just milliseconds, our little packet arrives at the destination server. But its work isn't quite done yet. Remember all those layers, all those envelopes we added at the beginning? Well, now the server has to unwrap them all. The Ethernet frame gets tossed, the IP header is read, and the TCP envelope is finally opened to reveal that original pristine HTTP request. Please send me this web page. And here's the kicker. The part that's truly amazing: the server then does this entire process in reverse. It takes the web page you asked for, breaks it into thousands of new packets, and sends each and every one on its own journey all the way back to you. Your browser catches them all as they arrive and seamlessly reassembles them into the page you see on your screen. And get this isn't just happening for your one click. Every single day, over 2.5 quintillion bytes of data are created. A quintillion? That's a number with 18 zeros after it. It's almost impossible to imagine. And every single byte travels as an individual packet, just like the one we followed. So here's a final thought for you. The core ideas we've just seen, encapsulation, packet switching, they were designed way back in the 1970s. It is an absolute testament to their brilliant design that they still power our entire world today. But as we connect trillions of new devices to this network, the big question is, how will this elegant but aging system evolve to meet the incredible demands of the future? It's something to think about. Thanks for joining me on this journey.